Hey everyone. So in this video, I'm going to talk a little bit about just exploring what the TVM Solver app on the TI-84 actually is and what it does. We're going to be making a lot of use of this app as we work on all of our calculations about saving and borrowing money, anything where we're making regular payments or deposits. And essentially, that's because the actual formulas involved here are just really awkward to use. They have a lot of details, there's a lot to keep track of, it's hard to calculate, and so whenever we have something that's awkward to calculate, that's what computers are for. In fact, these regular payment calculations were one of the very first things that you could do on a home computer way back in the late 70s. As soon as people started to have a computing machine in their home that they could put programs into, they wanted a program to do this calculation because nobody wants to do this by hand. So to access the TVM Solver, on the calculator you want to find the Apps button. Depending on the exact model and version of the calculator you have, you might have a whole bunch of applications here. But the very first one is Finance, and then the very first option there is TVM Solver. So this is the TVM Solver app. You might be wondering, what is TVM? TVM stands for time value of money, which refers to just how the value of money changes over time, which is one of the ways that we can think about what interest is and what it does. Interest, in a sense, reflects the fact that it's worth more to me to have $10 today than to have $10 next year. So if you want me to give you my $10 to use for a year and give it back later, I'm going to charge you interest. So that's what the time value of money is. And that's what the TVM in the TVM Solver name refers to. And now when we go to this, we have this whole list of values. And each of them represents something. They'll always represent the same thing. N is the number. Well, there are two ways to think about this number, and they'll be the same for us. We can think of this as the number of regular payments, or we can think of it as the number of times the interest compounds. And for our purposes, these are always going to be equal. Sometimes we'll be given this value directly. Say we're told we're making 10 payments, and sometimes we'll have to calculate this value. Say we're told that the interest compounds 4 times a year for 10 years. Either way, both of these values, the number of payments, the number of interest compounds, will always be the same. That I%, that's the annual interest rate. And unlike what we do when we're using the formulas, we can just leave the interest rate expressed as a percent. That's really convenient, right? It means that we don't need to do that dividing by 100 thing to convert to a decimal, right? We just have the interest rate in the form that we want the interest rate in. So it saves us a step, it saves us an opportunity to make a mistake. Now these next 3 values you can think of as being related to each other really strongly. PV stands for present value, PMT stands for payment, and FV stands for future value. Now don't get too hung up on present and future here. What these refer to is when in the life of the loan or account or whatever, the money that we're talking about changes hands. So PV, this is the value at the beginning. So if we make a lump sum deposit into an account, or if we take out the loan, that amount is our present value. The FV is what we have at the end. So if we have an account earning interest, the FV is what we have after all of the interest has been earned. If we're making regular deposits into an account, the FV is what we have in the account at the end. If we have an FV in a problem involving a loan, that means that we have to pay off a lump sum at the end of the loan period. And then the PMT, the payment, is an amount of money that changes hands regularly during the life of the loan or the account. So you can think of the story of an account is you start with the present value, and then PMT happens regularly along with interest, and you end up with the FV. Right? You can think of those as moving through time. Start with the present value, then you make payments while the interest is happening, and you end up with the FV. And then the last item here, we have P/Y and C/Y. This is payments per year and compounding per year. And just like the number of payments and the number of times that the interest compounds overall, these are going to be equal. Okay, so there are going to be two main ways that we deal with this TVM Solver app, but there are lots of other ways that you could deal with it. Right? You should take a little bit of time to play around with this and see what happens. The first scenario that we're going to be looking at with this app is a scenario where we start out with an empty account, we make regular deposits while we earn interest, and we end up with some money saved. So, for example, we might make monthly deposits of $50 for 2 years at 3% interest. So let's figure out how that translates into the Solver app. Well, if we make monthly deposits for 2 years, monthly deposits means 12 times per year. 2 years means 2 years. My number of deposits will be 12 deposits per year times 2 years. I could work that out separately, but I'm in a calculator right now. I can just punch in 12 times 2, that's 24. Next I want to say, okay, my interest rate, that's 3%. So my I percent is 3. I'm making deposits into this account, and I don't have anything in here to begin with. So my PV, the amount I start out with in my account, is 0. But then I deposit $50 every month. And presumably I want to know how much money I end up with. The last thing I need to fill in, again using the fact that the deposits are monthly, is that my payments per year is 12. And my compounding per year is assumed to be the same. Now that I've entered all my given information, if I want to know how much I end up with, in order to find this value, I need to use the solve function. I notice the solve command is in green above the enter key. Notice the alpha key here is green. To get the green command, we want to press alpha, and then whatever key the command is above. So this tells us that at the end of 2 years we have, I'm going to just round to the nearest dollar, $1,235 in this account. Right, so that's more than we put in. We put in $50 per month times 12 months per year times 2 years. So we put in $1,200. That means we got $35 in interest. That's not very much. That's because 3% interest isn't very much interest. and 2 years isn't a very long time. Now, the other kind of scenario that we're going to think about is one where we start off with a bunch of money and we get rid of it all. Usually we're going to think about that in context of a loan, where we borrow a bunch of money at the beginning and then we pay it all off. So in these cases, our FV will be 0. We will usually see this in the context of loans, but it doesn't have to be in the context of loans, right? We might have a bunch of money in an account that we're getting in regular payments. So in that case, we start with a bunch of money in the account, we take out money regularly, we want to end up with no money at the end because we want to spend it all. So, but the example I'm going to give is a loan. We might say we borrow $1,200 and then we're going to pay that off in 8 monthly payments. And implicitly we're wondering, what are the payments then going to be? So we don't need to do anything special to clear out the app on the calculator. We can just put in the new numbers on top of the old ones. In this problem, we're told that we're going to make 8 payments. Notice this told us how many payments instead of how long we're going to make the payments over. That can happen. You have to be careful when you're reading the problem. Is this telling us an amount of time or just telling us directly the number of payments? So here we're told directly the number of payments. It's 8. So we fill in n equals 8. Our interest rate, well, that's 11%. We borrow the loan before we pay it off. So this $1,200, we get that at the beginning. That's our PV. We're trying to find the payment. So for now, I'm going to leave a 0 there. We'll come back to it when we have all of the information entered. And then by saying that we pay it off, that's what's telling us that our future value is 0. If we aren't told anything about where we end up with a loan, we'll assume that we want to pay it off at the end. So again, we'll have future value 0. And then the last piece of information, these payments are monthly, so our payments per year and compounds per year are still 12. We're trying to find the payment, so we put our cursor back on payment and solve. And we need to make payments of $156.25, rounded to the nearest cent. I notice I rounded that down, so probably my last payment is going to have to be a little bit extra, right? Because $156.25 is not quite enough. That's something to be on the lookout for as you're working on the homework. Occasionally, the instructions will tell you to round up no matter what, to make sure that your payments are always enough to cover your loan. So, that's how the TVM Solver works. For this class, we will always have one of PV, PMT, or FV be 0. The reason for that is these problems get a little bit more complicated when they're all non-zero. In particular, notice how every time we did this, we got a negative number showing up. What that sign on that number does is indicate the direction that the money is going. And so if you want to have more than one of these be non-zero before you solve, right? If you want to have all 3 of them end up as non-zero numbers, you have to pay attention to those signs in order to get the directions right? Like an account that I start off by putting $8,000 in, and then I deposit another $50 every month, is going to be very different than one that I put $8,000 in and then withdraw $50 every month. So we would need to keep track of the signs for that. That's outside the scope of this course. For this class, we'll always have one of PV, PMT, or FV be 0. We will also always have payments per year and compounding per year be the same as each other. And that's basically because allowing those to be different makes the problems harder to read and the information harder to find without actually adding anything to the meaning of the problem. So whenever you find in the problem the number of payments per year or the number of compounds per year, you can use the same value for both of those.